Hey, what's up guys? Dr. Sharp here with a fundamental geometry lesson. So for today, pretty simple. We have four main learning objectives. Our first one is going to be looking at 30, 60, 90 triangles. Second one, we're going to look at some semicircles. Third one, we're going to get used to isosceles triangles. And lastly, we're going to look at some irregular shapes so you guys can know what those look like. Alright, so let's get started off with the 30, 60, 90s. So 30, 60, 90s, they're the most common type of triangle, and they show up in quite a lot of places. So I'm going to just draw this one out for you guys so you can visualize it. Let me get a bigger pen here. So that is what all 30, 60, 90 triangles will look like. And in all 30, 60, 90 triangles, there's going to be a notation in the corner with 90 degrees that is kind of makes it a little square like that. And that's how you know that this corner is the one that is 90 degrees. So to find the other degrees of both this angle and this angle, you use what you already know. So you know that this is 90 degrees, and you know that the entirety of the triangle is 180 degrees. So from that conclusion, you can take the bigger angle and assume it is 60 degrees, and take the smaller angle and assume it is 30 degrees, which would be correct because it is a, as I mentioned, 30, 60, 90 triangle. Something else to note is that the sides also correspond with the angles. Since this side right here is the longest side, then this side is the biggest angle. And since this side right here is the shortest side, then this is the smallest angle. Alright, so now we're going to move on next to semicircles. So semicircles, not going to get too in-depth on that right now. We're just going to kind of lay it out for you guys what it is. So semicircles are half of a circle. And why it's important to know that for the fundamentals is because most people know that a full circle is 360 degrees. This is the entire circle all the way around. But a lot of people have trouble starting to break it up. So if we just look at the top half of the circle right here, then that's only going to be 180 degrees, which is half of 360. And then it can be broken up even further into segments of 90 degrees. Because if we have 4 segments of 90 degrees, then that equals 360. So kind of just keep in mind that as we work more with circles, that 360 is going to be the entirety of a shape, and if you're working with a semicircle, it's going to be 180 degrees in this center line right here. Alright, next we got isosceles triangles. So since this is just a fundamental course, I'm gonna just kind of go over this one pretty quickly. So isosceles triangles are triangles where 2 of the sides are the same length, but the base is a different side, is a different length. So as you can see in this one, this example of an isosceles triangle right here, the base, which is this one at the top, is only 6 inches. But the side that we have is 10 inches. And so using that knowledge, we can find x, which is the missing side. And because isosceles triangles have 2 same sides, then we know that x in this scenario is also 10 inches. And then from that, we'd be able to do more calculations. You know, we can find the area of that triangle if we want. We could, you know, stretch it out, you know, because we know that that equals 180 degrees and all that fun stuff. So there's plenty we can do. It's just important to get those fundamentals down. And lastly, we're going to be covering irregular shapes. So irregular shapes are something that they're everywhere, but you know, sometimes they mean something, sometimes they don't mean something. And in an example like this, as you can see, one of the sides is 1 inch, the other is 2 inches, and like one of them's 4. There's a weird little like thing going on over here. It's you can normally visually tell when a shape's irregular, and then you'll be able to pick out whether it can even be found the area of. Like, normally you can break up irregular shapes into smaller shapes to find the area of it. But I just kind of want to, show an irregular shape and get that out there. Keep that in mind as we advance in the chapter. So you can see here, like breaking this up into just a simple thing like this, that creates a 36U90 there. This creates possibly an isosceles triangle of sort in this section. This might not be findable, could be a square. And this could be a sort of trapezoid too. We can break this into a rectangle, and then we're left with a triangle here as well. So just kind of want to show you guys that there's plenty of ways you can break up shapes into different things. And yeah.